Okay, 7.2. Probability distributions, expected value. Okay, so there's a lot of reading in this, so I want to please read through these pages. There's no point in me going over it, but I'll highlight the important parts. Expected value. So probability distributions, first of all. I want you to read this, just look over these. Expected value is what we're going to concentrate on. It's a bit blurry, but again, you have the book. There we go. Expected value is when you look at a game, okay, imagine a fairground game, and you want to see whether it's fair or not, and you do that by getting the expected value. What you would expect to get if you were to play this game a number of times, on average. Okay, so in general, the expected value is not one of the possible outcomes. So if the outcomes are 4, 8, and 12, the expected value, if that was 12 euro, 4 euro, 8 euro, the expected value might be 5 euro. It's not necessarily one of the terms. The same way in averages, they're not always one of the terms. I want you to take this off. And this means, if you want to explain it, the expected value of x is the sum of the probabilities of x multiplied by the value of x, each x. Okay, so I will explain what that means, but if you just take this down, this yellow box, and I'll explain it when we're doing examples, okay? And read through all this, and then saying, when is a game fair? Some people might say a game is fair when you there's a better probability that you're going to win money. No, a game is fair or equitable when the player's mathematical expectation is 0, if there's pretty much the same amount of chances you winning as losing. Okay, so that's when a game is fair. So flicking a coin would seem to be fair because there's a 50-50 chance. Whereas if something's biased towards you, it's unfair towards you. If something's biased towards the game, it's unfair towards the game. And what we're going to do is we're going to go through these two examples. First one's basic enough. So, and to be honest, a lot of you are bright lads, sort of. You should be able to look at some games and see whether they're fair towards you or fair towards the game. But to actually put a number on it. Alright, so the first one is circle is divided in their equal parts, okay? And then there's a spinner. Okay, there's a spinner somewhere. 6 equal parts. You pay 10 euro to spin this wheel. And the number it lands on is the amount you get back. So you can see there's 2 10 euros, a 30, 2 zeros, and a 5. So straight away I would look at this game, and to be honest, I'm not a gambler, but even if I was, I would look at this game and I go, there's only one square there where I'm going to win any money. Okay, or one section there I'm going to win any money. But we'll see what the actual expectation is of this game. And remember, the expected value is the value that if you keep playing this game, the average that you would expect to win or lose over that time. Okay? Because obviously you can spin it once and win 30 euro. That doesn't mean you're going to win 30 euro every time you play it, or on average you're going to win the 30 euro back. Remember, you've paid 10 euro for it, so you want to be, those 10 euros is just getting your money back. Right, so what is the expected amount you would win or lose in this game? So what we do is we list out the payouts. So the payouts are X. Payouts are 0, 5, 10, and 30. Your outcomes pretty much 0, 5, 10 outcome. And then you do the probability of each of them. So the probability. So the probability of 0 is 2/6. The probability of 5 euro is 1/6. The probability of 10 euro is 2/6. And the probability of 30 euro is 1/6. And all you do is you multiply the payout times the probability. So 0 times 2/6, 0. 5 times a sixth, 5/6. 10 times 2/6, 20 over 6. Again, you can put it as a decimal if you want. Actually, I think I might put it as a decimal just to... Oh no, actually, I'll leave it. Just to keep it the same as this thing, because you're dealing with money here. When you're adding them up, you can do it. And then 30 times a sixth is 5 euro. Okay. So the expected payout is this symbol that you took down in the yellow box. That just means the sum of x, the payout, multiplied by the probability of x. So the sum of all these, and that is equal to 0 plus 5/6 ordered as a decimal plus 20 over 6 plus €5, and that actually equals to, again, all you could do is type that into your calculator, change it back to decimal, €9.17. So if you were to play this, or this game was to be played, say 100 times in the day, on average, you would expect that the person would win €9.17 on average, which is a loss, because it's €10 to play the game. So €9.17 is the payout minus €10, because that's how much you paid. It's on average a loss of 0.83. So you can expect to lose 83 cents if you play this game. Okay, and it's not necessarily one of the numbers. 917 is not one of those numbers. But if you were to play this 100 times that day, on average, you would be down 83 cents a game. Okay, roughly. Okay, right, just pause there. This second example, the last example, to be honest, I wouldn't have played that game. I looked at this and I could nearly look straight at the numbers and realise that it doesn't look very favourable. It wasn't too bad. You might get away with it for a couple of spins if you're going to be repeatedly playing it. This one's a bit less because there's more permutations, less to see here. So any double, €2 to play. Any double, €4. Okay. Total of 7. If you roll, so it's rolling 2 dice. Total of 7, €3. An odd number, except 7, you get your money back. Even number, except the double. So if you land on 6 and it's a 4 and 2, you lose €3. If it's 3 and 3, that's a double. Okay. So you're looking at it. So what you need to do is you need to list all the outcomes. Okay, you need to list all the outcomes, and we list outcomes of 2 events if you're looking for all the outcomes. Do you remember in a sample space diagram? So we'll go down 6 and across 6. Again, you could list them the other way. It's just to list off all. You could put these at the top. Actually, I'll just do it the way we would have done it in 3rd year, just to show you it can be done either way. It doesn't make it in 3, 4, 5, 6. So that's dice 1, and then 1, 2, 3, 4, 5, 6. And do you remember 1 and 1? So the scores are added together. So 1 and 1 is 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. 4, 5, 6, 4 and 1, 4 and 2. Okay, I remember in 3rd year we would have been doing listen them out this way, but again it's the same to do it the other way. It doesn't make a difference. So now we can see all the different possible outcomes. Now, how quick did it take me to do that? Like a minute. Okay, so it's better to have it all laid out in front of you. This is what this is used for, to have it all laid out in front of you, all the 36 outcomes, rather than you thinking each time you're looking at one of these. Okay, let's see what the questions say. Calculate the financial expectation of this game. Okay, so this is part 1. Calculate the financial expectations. What do you expect to get? So the first scenario, any double. So how many times is there a double? So the probability of a double is equal to 1/6. Well, actually, we'll lay it. Unlike the book, we'll lay it out like we did the last one. So we have the payout. So the payout is €4 for the first one, €3, €2, and then minus €3. It's a bit harsh. If you get an even, you've got to pay another €3. The probability of this, so this was x, probability of x, again we can see it. So the probability of any double is 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. So there's 6 out of 36, or 1/6. The probability of a total of 7, there's 1, 2, 3, 4, 5, 6, 6 of those again, so it's 1/6, 6 out of 36. The probability of an odd except 7. So you count all the odds except 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 36, which is 1/3. And the probability of an even except the doubles. Okay, an even except the doubles. So that's a double. So it's pretty much, I'm going to count all the doubles just so I'm clear. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 doubles. But we've already counted 6 of them, sorry, 18 evens. We've already counted 6 of them as the doubles. So it's 12, that's 1/3 as well. Okay, and they've done this out in a bit more detail in the book, so you can have a look at that if you're unsure where I'm getting those numbers from. And then the x times the probability of x is 4 times a sixth, 4/6, 3 times a sixth, 1/2, 2 times a third, 2/3, and minus 3 times a third, minus 1. When we add up all of those, add up that, and that, we get 0.83. Okay, 0.83. So you would expect a payout of 0.83. Now, just be careful, you have paid €2 for this game. So 0.83 minus €2 equals minus 1.17. You would expect to lose €1.17 per game on average. Now, to be honest, most of these games, if not all of these games, you'd expect to lose because the person organising them has arranged them that way. Otherwise, they're not going to make any money. They sell this game to you as in, oh, you could win. So that €30 would be the one to, and the last one was to entice people in. Okay, the second one says, is this game fair? Explain your answer. And the answer, it's in the book there. The game is not fair as you expect to lose €1 each time. For this game to be fair, this 117 would have to be 0. Alright, so there's a few different questions that I'm going to give you. Any questions, please ask.